Okay, welcome back. This is another video, basically another conversion video we're going to do. This is version 30, and this is the motion sequential function chart where they dynamically change the speeds and everything. So what we're going to do is basically the same scenario we did, right? So first and foremost, what I want to do is change the versions. For one, I'm going to just, they won't let me change it right here. But what I will do is take it to an emulator. And then we'll go ahead and save it to a L5K, change the version. Let's see, we want second. Not sure why they won't let me. Okay, so probably because they have an emulator now of 30. So let's just go ahead and do that. Let's save it as the gear change. Then we're going to save it as a L5K. We'll minimize this. Gear change L5K. Again, the top features are the basically your internet version, which we know is 19 for the version we're doing. The major revision, right? So 28, and then come down here to where the processor is, and again change it to 28 and minor revision 0. Okay, so at this point we'll save and we'll open our project up, and then we'll basically open it. And what was it? Gear change L5K. Yep. So we want to replace it. So it's actually making the file now. And we're going to go through and try to make this one a little bit quicker. But again, show you how to put virtual axis in where the standard axis in the sample code, and actually go through and get the virtual axis working. So as we run into problems, we will fix them. So hopefully, we'll see. So right now it's still making the file. Just going to go through and go through the motions. Okay, so now we'll go through, we'll verify we're in processor 2. We'll add the virtual axis. We'll call it again virtual axis 0, and then virtual axis 2, so the axis, 1. Okay, and we'll get rid of, actually we won't get rid of them just yet. What we will do is go ahead and fill out our dynamics. So let's just call this 200, 3,000, 3,000. Let's calculate this again to 50%. And mouse is a little shaky. Okay, so 50%. Same thing here, 50%. All right, apply changes, and these are just on the axis we just made, right? So it's not a big deal. This is standard. It's not like, I think if you're familiar with the axis, or you can take the code as you want. You take the code straight from Rockwell's sample library and do the same thing I'm doing. I'm not doing anything very special, I don't think. So again, now we open up this code they have here. Again, so back to changing these from motion axis on to a motion axis home. Then we'll call this V2 RB. Let's see, B axis 1, right? Motion axis home. Of course, the tag's not there, so we'll make the tag. Okay, good. And same thing here. Motion axis home. And V. Change the tag name. Okay, so sorry, I like to keep everything capitalized. Okay, so that's done. All right, the gear ratio 0. We change these to V and V. Cool. All right, so down here, input 1 to 3, we're going to have to simulate those as we did. Not a big deal though. We'll change this to V, V, and then V. Okay, so that's going to be done. Okay, and then this is going to be V. Okay, so in the jog, we're going to be jogging. We're going to be jogging the. Alright, so, and it's looking again for some real world inputs, so we'll probably have to simulate those. Again, this off stuff, what we'll do is we'll change it. They spelled the tag wrong. That's from the factory. Okay, so yeah, we'll just change it. It's not gonna work, right? So I just want to I want to get the axis 1 tags out of there for what I want to do. So cool. So that's done. And we'll comment this out. Okay, so now the code is done except for the driving logic for, you know, this inputs and stuff. So we're going to be looking for, let's just make sure that we have all this correct. So V. All right, so this is looking for virtual axis, gear ratios, input 1. We can simulate the inputs and we'll probably do that. I guess we can go through here and simulate the input. We can add a I don't know. Yeah, there we go. Okay. So what I want to do is add a new routine. And I want to call this input sim. And then basically I'll have it call like the JSR or something. So just like they do down here, right? So basically just, we'll do the same thing. We'll copy this, copy that, and then come up here and paste. And then we'll call that, instead of ladder file, we're going to call it input underscore sim. And then what that's going to do is going to scan and it's going to pick up, of course, the loop and everything is something that could get done too. But what that's going to do is basically scan this, and then we'll pick in increments, you know, different ones at different times. That way we'll have the choice, right? So if none of these are active, it's not going to do anything. If one of those are active, it will do something. So real quick, let's just verify that I did everything in a proper manner, and we'll download. Now I explain to you what we're going to do as far as the code simulation. So I hope these videos that I've been doing like this are helpful, you know, in showing you how to simulate stuff and grow and kind of get used to this stuff. It's because, I mean, if I can do it, anybody can do it. So right now, just like I said, it scanned through here, like cut it, so both axes are 0 now. Actually, let's go back offline. I forgot to kill these. So what you want to do, you want to get rid of the other axis, so you want to make sure the motion group cuts on. You've seen that in the other, if you watch the other video, you've seen exactly why, right? They won't do anything until they're cut off, or until they cut on. And if the whole group is not happy, then it's not gonna, if the motion group is not happy, it's not gonna cut anything on. It's not gonna initiate any commands. It's not gonna do anything. It'll try, but it won't do anything. So it's just something you kind of learn with servos. All right, so what we'll do is we'll have basically 3 rungs here, and we're going to be looking for input 1, 2, and 3, right? So what I want to do is have 1, so we'll call this input 1. Was there a 0 in there? Oh, there was. Okay, so 1, 2, or 0. Okay. Alright, so let's change him to 0. Let's change him to 1. Let's change him to 2. And for the sake of time, I will just put toggle bits in here. So I'll put test bits, and then we'll just I don't know, we'll make that again like 3 or something. Don't need to be that big, but whatever. And we'll take that there, and there. Okay, so what I'm going to be doing is simulating the inputs. So this sequential function chart is not going anywhere until I sequence these, right? So this is going to go, if we recall, this is going to go to B5, and you can click right there to see it. Or we could show wire, but you'd have to edit, and I'm not going to edit while I'm online. So C5 again is right here, and of course that's going to go to shutdown. So if we want to increase the ratio, we go to input 2. If we want to decrease the ratio, we go to input 2. If we want to increase the ratio, we go to input 1. Want to shut everything down and start over, we go to input 0. So real quick, let's do an input 1, and you see everything started. So now it should be jogging. Let's look, see what it's doing. And positions are jogging. Okay, so to verify that everything geared together as it's supposed to, and it did. Cool. Yep. So this is a negative and that's a positive. Right, so see they're both working working together. And as soon as so as soon as the input stops, right, then it's going to go. So if I drop the input, it's going to go right back to the point that it was at. So, and then the turn of if I go 0, right? So if I go 0, then it just sits there and loops down to here until the timer is done. And in which case it's not going to be done because I'm still holding the bit high. The timer goes done and then it starts waiting again for me to do an input. So let's do, what did we do this time? We did bit 1, right? So let's do bit 2 and I'll show you what goes on there. Okay, so we did bit 2, so we incremented the ratio, right? We did the ratio again, and then basically, so now we should be running at a slightly different ratio. So let's monitor our tags again, and the actual position of 0 is that's the start position, but you see the difference, right? Not very much, but there is, and we could cycle it again. So we could keep basically indexing this, and what's happening is it's just jumping through the sequential function chart, right? So it's just jumping through here the whole time. So the more I index it down, the more the ratios. So you see it's a -8 right now. So let's just keep doing that, toggling it off and on. And you'll see, like right now, it should be, if I do that again, the ratio is -9.5. So you see, all it was doing was basically jumping through here, jumping, and just kept looping back, right? So let's do that. Let's do it one more time, and let's watch the difference. So they're both jogging after they geared together. And let's look at the difference. So there's actually a lot bigger difference right now, right? So if you look at this number and this number, so the difference is it's a lot greater, right? Because the ratios are actually offset now. So that's just showing you the ratio change in the sequential function chart. You know how to control servos again through sequential function chart. How to cut them on, how to come down, and we basically are just cycling through, right? So this is continuously cycling, if you see it. So it's continuously, with holding that bit high, like I'm doing, it's continuously changing. So these are going to continuously, I mean, you see how fast it circulates, you can't even see it. So the point I'm trying to get at is basically we're having to simulate this stuff, but we can simulate it and we can test our code, and we know that we can control servos through sequential function chart, and it works well. Note that you have to write the equation out like you do with structured text. So basically, you know, you would find that if you went to the instruction help. So if you went to instruction help and you went down to motion, right? So motion instructions, and then you went to let's see, where's a good one? Like a jog or something. So let's just pick a jog. That's motion states, motion move. So there's jog right there. So this is the way you would write a jog in structured text. So that's everything you would put in the structured text, and that all coincides with what's going on here. So if you looked, that's exactly what they did here. Right, so that's a jog, and they wrote out everything they're supposed to. Right, so the axis one, this is the instruction, this is the direction or the motion type, the speed, the units per second, basically breaking down every attribute of this, right? So anyway, so to kind of go over that, to show I made this one a lot quicker. I just wanted to show that you can simulate it, change the version. Again, this is version 28. So that was pretty much it. So to wrap this one up, short and sweet, hopefully that was helpful. And if you need to, feel free to email me or leave me a note below or something. And for those that are asking about screen resolution, these are done in high definition. If you just look at the bottom right hand corner of the YouTube video, you will see you can change your resolution, and you should be able to see a lot better resolution. That is if your internet connection is better. I am recording these in high definition, so you should receive them in high definition. So hopefully, and if I will be posting these again on my website. Probably not this weekend, but I will be posting them on the website sometime. And again, you can contact me on my Facebook group, or you can contact me through my website, which is Online PLC Help or onlineplcsupport.com, and that will be linked below in the show notes. Again, hopefully this was helpful to you, and look forward to speaking with you. Thank you.